How's it going, everyone? So unfortunately today I can't be with you. So instead I've created this video that's going to guide you through our notes. So hopefully you have a copy of this and we're going to go through it together. I guess the theme for this lesson is to see how our favorite classes are related. Okay. Is your favorite elective class associated with your favorite core class? We're going to collect some class data to see if there's a relationship. So if we were doing this in real time together, I'd have you guys go up to the board, but since I'm pre-recording this video, I'm just going to make up the data myself. Okay. All right. So let's say we surveyed a class of students and 10 students prefer art, 7 prefer music, 12 prefer PE, 9 foreign language, and 13 technology. Okay. So I'm going to ask you to pause the video here and go ahead and answer questions 2 and 3, and then when you're ready, you can unpause the video to check your work. Okay. All right. So question 2 wants us to identify the individuals of this data set as well as the variable. Okay. So the individuals are going to be the students that responded. And then the variable is going to be essentially the question that they were asked, so what their favorite elective was. Okay. So we can really break it down quite simply. The individuals are who the data is about, and the variable is what the data are about. Okay, so when you think of like the 5 main questions, who, what, where, when, why, okay, the who and the what is the most important characteristics of our data set. Okay, who are these data about and what was measured in this data set. Okay, question 3, is this variable categorical or quantitative? So this variable of your favorite elective class is categorical. Okay, so we're not recording, we're not measuring anything. We're just kind of counting how many people belong in each group or in each category, hence categorical. All right, question number 4, we're going to create a bar graph and a pie chart using some online technology. So there's a really cool website called Staplet. Okay. That comes in very helpful. It's more helpful than, say, even your graphing calculator for creating some nice statistical graphs. So we're going to go ahead and head over to that website, type in our numbers, and then create some graphs. Okay. All right, so here it is, staplet.com. There's a lot of different graphs that you can make here. We're going to pick the first link, one categorical variable, a single group. All right, we're going to go ahead and type in the variable name, favorite elective class, and then we'll type in the categories. We have art, and that was 10, music, 7, okay, PE, 12, foreign language, 9, and technology, which we had 13. All right. So now we can just click the button that says Begin Analysis. Okay. And the first thing that we're given is a bar chart. Okay. So right now it's showing the frequencies. And one thing I want to point out is, first off, the labels, right? So notice that the horizontal axis has the name of the variable, right? Favorite elective class, and then we have the names of the 5 groups, okay? And then the vertical axis has a label as well. It's labeled as frequency, and notice how it starts at 0. Okay, that's very important. We don't want to start at a higher or lower number. We want to start at 0 so that we can see the accurate differences between the size of these groups. Okay. If, for instance, we were to start, say, at 6, right, then it makes that second group seem extremely low, and it makes the first group look like it's more than twice its size, okay, which is not accurate. Okay. It's the number of students who like art is not twice as many as the number that like music. So we have to make sure that we always start that vertical axis at 0. Okay. If we click here, we can change to a different graph. So for the notes, it asks for a pie chart as well. Okay, and so we have here like 5 different slices of the pie. Each colored slice is representing one of those 5 elective classes or groups. Okay. All right, so you can go ahead and take a moment to sketch both the bar graph and the pie chart onto your note page. Yeah. All right, and now what we'll do is we'll take a look at a situation where maybe we want to investigate more than just one variable. So previously we had just the one variable, favorite elective class, and now we're going to see how that is related to somebody's favorite core class. So we're just going to break it up into the 2 main core classes, math and English. Okay. So because we can't, physically collect our own class data, I'm just going to make up some numbers here. And so let's say that for the group of people who like math over English, 7 of them like art as their elective, 6 chose music as their elective, and then we're going to have 8, 4, and 9 for those 3 remaining elective classes. And then for the group of students who prefer English, let's say the numbers break down the following way. 3 for art, 1 for music, 4 for PE, 5 for foreign language, and 4 for technology. Okay. All right. So again, I'm going to ask you to pause the video here. Go ahead and answer those 3 questions associated with problem 5 by calculating those percentages. And then you can also do questions 6 and 7. So when you finish question 7, you can unpause the video and take a look at the solutions. Check your work. All right, so for question 5, they want us to figure out all these percentages. And so we actually need to do something before we calculate the percentages. We need to figure out the row totals, the column totals, and then the grand total or the table total for this data set. Okay. So I'm going to add an extra label here that says total, and we'll add an extra one over here that says total as well. And we're just going to start adding this up. Okay, so we have 10 students overall that like art, 7 that like music, 12 that like PE, 9 that like foreign language, and 13 that like technology. That should add up to 51. And then if we add down the columns, so if we figure out how many people prefer math as their core class, those numbers add up to 34. The number of people who prefer English for their core class, those numbers add up to 17. And yes, 34 and 17 also make 51. Okay. So now we're ready to tackle the questions about percentages. Because remember, a percentage is based off of a fraction, the number of the part to the whole, for instance. Okay. All right, so what percent of all students, there's a typo there, percent of all students, who chose PE. Okay. All right, so how many total students chose PE? That would be 12. How many total students are there? Because we're looking at all students. That would be 51. And 12 out of 51 is roughly, let's just round that to 24%. Okay. So 24% of all students surveyed like PE. All right, next question. What percent of all students who chose, find the percent of all students who chose math and art. Okay. All right, So we're looking at all students, so that tells us the denominator should be 51. That's how many students there are all together. And let's count the number who chose math and art. Okay, so math and art is just going to be that 7. Okay, so 7 out of 51 gives us a percentage of about 14%. All right, so 14% of all students surveyed chose math and art. All right, and then now for the last one, which is a little bit different, because notice it doesn't say percent of all students. It says percent of students who prefer math. Okay, so how many students did we have that preferred math? That was 34. Okay, so that's going to be our denominator. We're no longer looking at the entire group of all students, just that subgroup that prefer math. Okay, and so out of that subgroup of 34 students, we'd like to know the percent that chose technology for their elective, and that would be 9 of them. So 9 out of 34 is about 26%. So these percentages have names to them. We call them different things. Okay, this one here is called a marginal percentage, or another name for percentage in stats language is relative frequency. This percentage here is called a joint relative frequency. And then the last percentage is referred to as a conditional relative frequency. All right. So the marginal relative frequency is called that because it uses numbers that only come from the margin, right? 12 came from the margin of the table. 51 also came from the margin of the table. Okay, so that is kind of how it gets its name, marginal relative frequency. The joint relative frequency gets its name because it's looking at kind of like the joint intersection of two things, right? So we're looking at math and art, so we're looking for where math and art meet, so we're kind of looking at that joint number, or that number in the intersection of the row and the column. The conditional relative frequency gets its name because we are not looking at the entire group of students. Remember, it never said all students for the third question, but we're looking at a subgroup, or there's some condition that we have first, right? So the condition was that we were only going to look at students who prefer math. Okay, so in this case, we only look at one, say in this case, one column of the data. We can ignore everything else in the table. Okay, question number 6. How many variables does the table have? Are the variables categorical or quantitative? Right. So that table there has just 2 variables, right? Favorite core class and favorite elective. So there are 2 variables, which are favorite core class and favorite elective. Okay, and again, they're both categorical because we're just, placing people into groups, right? Math or English, right? Which group do you fall into? Art, music, PE, foreign language, or technology. What group do you fall into? Okay. We're not going to see any quantitative data in this lesson today. Okay, that'll be saved for another day. But quantitative data is when you're recording things with numbers. So usually you're measuring something, a height, a weight, a dollar value, for instance, time. Okay, all of those things are measurable, and have units. All right, number 7. Which variable would best explain or predict the other variable? Okay, so the best way to think about this is which variable would you record, or would you know the response for first? And I would argue that people probably know at a very young age whether they like math or English better, right? You start learning math and English when you're in elementary school. You don't necessarily start learning foreign language or music at such early age, but kindergarten, you're already learning math and English. So I would argue that at a very early age, it's already established. Most people establish whether they're like a math or an English person. And then later on, when they get to middle school and high school and they start taking elective classes, then they, determine which one of those they like. So if we think about it just kind of like in a chronological order, people would first determine what their favorite core class is, right? And then we can use that information to then later predict what their favorite elective class is going to be once they get to the middle school and the high school level. Right. So the variable that we think is explaining things or predicting things, we call that the explanatory variable. And the variable that we think is responding to the other, or maybe think of it as the outcome variable, that's called the response variable. Okay. All right. At this point, we're going to go back to Staplet and we're going to make some graphs for this two-way table data. Okay. We're going to make a side-by-side bar graph, and we're also going to make a segmented bar graph. Okay. All right. So going back to the main menu on staplet.com, we're going to click on the two categorical variables, okay, because that's what we had. Okay, our explanatory variable was core class. Our response variable was elective. Okay, we had math, we had English, and we had art, music, PE, foreign language, and technology. Okay, and the numbers were, what were they? 7, 3, 6, 1, 8, 4, 4, 5, 9, and 4. Okay. All right, let's click Begin Analysis. All right, so the default graph that they give us is the segmented bar graph. So this is kind of like a pie chart. A pie chart is a circle where everything adds up to 100%. A segmented bar graph is just a rectangle where the different colored pieces or the different colored segments sum to 100%. Okay, so there's two rectangles because we had those two subgroups, the students who prefer math versus the students who prefer English. And within each of those subgroups, we have our 5 categories for their elective. Okay. And then let's look at the side-by-side bar graph. Okay, so instead of stacking the different color segments on top of each other to make a full rectangle of 100%, we just put the little colored segments side by side next to each other. Okay, so all the colored segments for math are grouped together, all the colored segments for English are grouped together. Okay. Personally, I prefer the segmented bar graph. Recently, I would say that this is becoming a lot more common on the AP exam, right? Seeing these segmented bar graphs versus maybe a side-by-side bar graph. Okay. All right, so go ahead and practice, play around doing this yourself on Staplet, and copy these graphs onto your notes. And then we're going to go on to number 9. Okay. So how do the bars in the side-by-side bar graph relate to the bars in the segmented bar graph? Okay. Well, I can see here that, in the math group, right, that dark blue bar is 20%, And when I look at the segmented bar graph, I can see that it's still 20%. Okay. Let's look at, for instance, the light blue bar graph. Sorry, the light blue bar for the math group. That's those that like music. It's about, I don't know, somewhere between 15 and 20%. And in the segmented bar graph, if you were to figure out the size of the light blue segment, it would be about, it should be the same percentage. Okay. So they are the same size. It's just in the side by side, the bars are all just placed on the horizontal axis, whereas in the segmented bar graph, the bars are stacked on top of each other. But they represent the exact same percentages. All right, number 10, is there an association between favorite core subject and favorite elective? If so, describe it. So basically, we're going to try to see if we notice any patterns between our two subgroups, right? People who prefer math versus people who prefer English. So a lot of the colors are roughly the same size when I compare the two rectangles, like the green segments are more or less the same size. The dark orange segments are about the same size, and the dark blue segments are about the same size. So I see that there are some similarities, but let's see if I can spot the differences. And we're going to first look at the light orange segments, right? So I can see that for our math folks, they're less likely to prefer foreign language, right? Their light orange segment is pretty small, and English folks are much more likely to prefer foreign language, okay? So there's kind of one difference between our two subgroups. And then there's another kind of noticeable difference if you look at the light blue segments, right? We can say that our math folks are more likely to prefer music, and English folks are less likely to prefer music. Okay, so those are two kind of key differences we can spot just by comparing the sizes of the different colored segments here. All right, 11. If there was not an association between a student's favorite core subject and their favorite elective, what would the graphs look like? Well, if there was no association, that's another way of saying that there's no difference between our two groups of students, math students versus English students. Yeah. So if there's no difference, then the percentages we see or the size of the different colored segments would be more or less the same. It doesn't have to be exactly the same, but it would be roughly the same. So oops, let's sketch a picture of what that might look like. Math, English, and then I want to include the name of the variable, which is core subject. Okay, and then over here we're going to have our percentages from 0 to 100%. Okay, put 50% in the middle. Let's 10, 20, 30, 40, 60, 70, 80, 90, and 100. Okay, and then we can label this percentage. Or if you want to sound fancy, you can write relative frequency. All right, so for each subgroup of students, we're going to have a rectangle that goes all the way to 100%. Just like if we were doing pie charts, the entire circle would represent 100%. And then we're going to divide it into 5 segments representing the 5 different electives. Okay. Now, no association means that there should be no to little difference. Okay, so the percent of math students that like art would be more or less the same as the same percent of English students that like art. Okay, we'll make a little key over here. So this color is art. Okay, the percent of math students that like music is going to be more or less the same percentage as English students that like music. Okay. And then we'll just go through all the different electives. So this will be PE. Okay, so we want those percentages to be more or less the same. And then let's pick another color, orange. All right, this is going to be foreign language. And then one last color here. This is going to be technology. Okay. So if our two rectangles have segments that more or less are the same size, then there's really not any differences between our two groups. And so if there's no differences, we just say that there's no association. All right, so now we'll move on to the back side. We'll go over some formal notes, and then I'll have you pause the video. You can do the two check your understanding questions, and then unpause when you're ready to check your work. Okay. But first, let's go ahead and take care of our formal notes. Okay. So this lesson is all about categorical data. Okay. And so the way we record categorical data is by recording the counts, like how many people fall into each group, or the percentages, right? What percent of people fall into each group. Okay, so we record frequencies, right? That's just our fancy word for counts, or the relative frequencies. Okay, which is just our fancy word for percentages. Okay. And the way we like to display categorical data is with all the techniques we saw in the lesson. So bar graph, pie charts, side-by-side bar graphs, or that segmented bar graph. So display as bar graph, pie chart, side-by-side bar graph, or segmented bar graphs. All right, we talked about it a little bit about how one might mislead with a graph that doesn't start at 0. So we'll talk a bit about misleading graphs. Okay, so you really just want to be careful when it comes to that vertical axis, right? It always needs to start at 0 so that we're showing the most accurate differences between the groups or categories. And we didn't quite see it in this lesson, but you'll see it probably in your AP Daily videos or as you're reading the textbook about pictographs. So you want to be very aware of what's called pictographs. Okay, so a pictograph is what we would get if, say, we replaced the bars with a picture. So I don't know. Like for PE, instead of drawing a bar for PE, like maybe we drew a baseball or a basketball, right? And the issue that comes up is as you increase the size of a picture, its height increases, but the width of the picture also increases, which distorts the value that picture is trying to represent. Okay. The thing with bars is that they all have the same width. The only thing that changes is their heights. Okay. So that's the reason why we don't want to use pictures and just use a simple bar instead. All right. And then let's talk about the two-way tables. Okay. And so in a general sense, what that's going to look like is a table that has rows and columns. Okay. The columns are going to represent the categories of variable 1, for instance, math or English, and the rows would represent the categories for variable 2. All right, so the example we saw again was elective was the second variable, core class was the first variable. All right, if you're given a two-way table, you want to make sure that it shows the totals. And if it doesn't show the totals, then you just got to add them up yourself. Okay, so you want to make sure that you see all those row totals. You want to make sure that you're seeing all those column totals, and you want to make sure that you're seeing the grand total, which would appear right there. All right, so from a two-way table, there's a lot of different percentages or relative frequencies we can calculate. Okay. We can calculate a marginal relative frequency, and that would be, for instance, taking maybe a row total and dividing it by the overall total, right? So B over C. We might want to find a joint relative frequency. Okay, and that would be taking one of the cell numbers, so one of the numbers inside the table, and then dividing by the overall total. So perhaps A over C, that would be a joint relative frequency. Okay. And then a conditional relative frequency would be taking one of the numbers in the cells, so inside the table, so a number like in the position of A, and dividing it not by the overall total, but just by, say, a row or a column total. So B is a row total. I could do A over B. That would be a conditional relative frequency. Right, and then we'll try to squeeze one more little bit of note in here about what the word association means. Okay. Okay. So when two variables are associated, that means that knowing one variable affects information about the other. Okay. So association between two variables means that knowing one variable affects the other. So for instance, knowing if somebody likes math affects whether they would like music, right? I know that math people are more inclined to like music, right? Or knowing that somebody likes English has an effect on if they would like foreign language. We can see here that English folks tend to like foreign language more than math folks. Okay. But in this example here, right, knowing whether somebody likes math or English gives us no information about what elective they like, because the segmented bar graphs indicate that math and English people like the 5 electives at roughly the same percentages. Okay, so here's an example of no association. Right, knowing a core class tells us nothing, gives us no helpful information about what elective people like. All right, so this is another point where I'd like you to pause the video, work at your tables on questions 1 and 2, and then when you're ready to check your work, unpause the video. All right, so let's go over number 1. Let's see, the following graph was displayed by a national news organization. Explain why the graph may be misleading and sketch a corrected version of the graph. Okay. So we're looking at misleading graphs, and so if we look back at our notes, we see that what we want to do first is check the vertical axis. Is it starting at 0 like it should? Okay, and when I look at the vertical axis, it is starting at about 155,000. Okay, so there's a whole chunk of the bar that's not visible because the axis didn't start at 0. Okay, so what the effect that that has is it makes the data here seem like it's twice as much as that one, right? But when we look at the numbers, we know that 192,000 is not twice as big as 170,000, but the way the bars are drawn, it gives that perspective, right? That's not the word I'm looking for. I can't think of the word, but it gives that. I'll hopefully think of it later. Okay, anyways, let's draw a corrected version of the graph. To correct this, all we need to do is start at 0. Something else I noticed is that there's no variable here, and there's no label here, and there's no label over here. So we'll add some labels to the graph as well. Okay. All right, so start at 0, that's the most important thing. And just to make it easy, we'll say 200,000. So that's going to be 100,000, 150,000, and 50,000. This is just going to be a rough graph. Okay. We'll label this frequency because we're just looking at counts. Okay. What is this, by the way? Southwest border apprehensions. Okay. All right. So I can tell that the horizontal axis should probably be labeled year. And then we have 2011, 2012, and cannot write today, 2013. Okay. All right, so 165,000 in 2011, 170,000 in 2012, and 192,000 in 2013. Okay. So yes, border apprehensions are rising, but not as fast as this makes it seem, right? This graph makes it seem like, they're increasing quite rapidly when in reality they're not changing that much. Okay. All right, number 2. A real estate agent is collecting data on the number of houses built in his town's 3 neighborhoods during 3 different decades. Table below. So we've got the 60s, the 70s, the 80s, and we have the names of the 3 neighborhoods. Okay. So I noticed right away that there are no totals. So I'm going to go ahead and fill those in before I even read the questions, because I can almost guarantee that we're not going to be able to answer any of those questions until we have the totals. Okay, so I see that is 100. Let's see, 80, I think that adds up to 90. And this adds up to 30. Okay, 190 and 30 is 220. Okay, and then let's add up the rows. That looks like it adds up to 80. That looks like it adds up to 80. And that adds up to 60. 80, 80, and 60. 160, 220. Yeah. All right. Numbers seem to work out. Okay. All right. So question A. What proportion of the houses shown were built in Pinewood Estates? Okay. So it's saying of the houses shown, meaning of all the houses. And then specifically we're looking at Pinewood Estates. Okay. So I know that there are 220 houses shown in all, and the ones that were built in Pinewood Estates were 60. Okay, so we can write it as a fraction or convert that fraction to a percentage, which would be roughly 27%. Okay. B, find the distribution of decade built for the houses in this town using relative frequencies. Okay, so if a graph asks you about the distribution, it's basically asking you, well, you can make a graph to show the distribution. All right, so let's make a graph. Okay, we only want to include information about decade built, so we don't care about the neighborhood. Okay, and we're going to do it using relative frequencies, which again, that's a fancy word for percentages. Okay, so we need to find the percentage of homes that were built in each decade. Okay, so for the 60s, I see that there were 100 homes built out of 220. It's about 45%. For the 1970s, there were 90 homes built out of a total of 220. And that's about 41%. And then for the 1980s, there are 30 homes built out of a total of 220, giving us about 14%. Okay. Now those should add up to 100%, or like maybe 99 or 101, because I did round them a little bit. So when you round numbers, sometimes one percentage gets rounded up and you get a total of 101%, or sometimes something gets rounded down, you get a total of 99%. It happens every now and then, but it looks like those ones add up to exactly 100%. Okay. All right, so let's make a graph. Let's see, let's make a segmented bar graph. So I'm going to have 0 to 100%. Okay, 10, 20, 30, 40, 60, 70, 80, 90, 100. Okay, and then we'll have a rectangle representing 100% of homes built. Okay, so 45% of them were from the 1960s, so I'll just write the 60s there. Another 41%, so 45 plus another 41 should take us to about 86%. Okay, so that's in red, that's the other 41%. Those were homes built in the 70s. And then that last 14% were homes that were built in the 80s. Okay. All right, and we can give it some labels, percentage, and then just like decade, or decade built. Right, last question. What percent of homes were built in Oakcrest and in the 1960s? Okay. So it's looking for two specific outcomes, right? A neighborhood and a decade. So we can identify that, right? Okay. So there were 60 homes built in that neighborhood during that decade, but we want to know the percent, what percentage of homes, and it's not really written, but it's assumed that it's asking what percent of all homes. Okay. So we know that there were 220 homes in all, and 60 of them were built in the Oakcrest neighborhood and during the 1960s. And so 60 out of 220 is 27%. Okay. All right, thank you for watching this video. Hope you found it helpful, and I will see everybody very soon.